This is the mastery check for 5.03 and 5.04, solving one-step equations. The directions are to solve each equation and then check your answer. So remember that when we're solving, we are trying to find the number that can replace the variable and make the statement or the equation true. Another way to think about how to do that is to think about getting the variable by itself on one side of the equation. So when I look at A, here's my variable that I want to get by itself. Sorry, let me get my pen. Okay, here's my variable that I want to get by itself. And right now, what's keeping it from being by itself is that it's being multiplied by 2. So I want to undo that multiplication. I'm going to do the inverse operation of multiplication, which is division. So I'm going to divide this by 2, and that will get rid of my multiply by 2, so that I'm just left with A over here. But now when I've divided one side of my equation by 2, I have to do the same thing to the other side to make sure that these sides are both still equal to each other. So I'll have 15 divided by 2 over here, which I know off the top of my head is 7.5. But if you didn't know it was 7.5, you could come over here and do your division just like this, 15 divided by 2. All right, so now let's check that. To check our answer, we need to substitute 7.5 back into our original equation where A was. So I need to see, is it true that 2 times 7.5 is equal to 15? So then I would come over here and do my multiplication, and 2 times 5 is 10, 2 times 7 is 14, plus 1 is 15, and my decimal goes there. Obviously you can do lattice for that as well, but I got that this is equal to 15, which is the same as this, so my answer checks. Okay, let's look at letter B. Now the variable that we're trying to get by itself is right here, and what's keeping it from being by itself is that we're subtracting 8 from it, so we want to get rid of that subtracting 8. So to do that, I'm going to do the inverse of subtraction, which is addition. I'm going to add 8 so that I can get rid of that. And all I would be left with over here is just x by itself, since I got rid of the subtract 8. Over here, remember you have to do the same thing to both sides. So we added 8 over here, so we would add 8 over here as well. And then I have 13 plus 8 gives me 21 equals x. Now I need to check that to make sure that it's correct, so I'm going to substitute 21 back into my original equation where x was. So I'm going to see, is 13 equal to 21 minus 8? So I'm going to try 21 minus 8. I'm going to borrow, so 11 minus 8 is 3, 1 minus nothing is 1. So I get 13 over here, which is what's on the other side of the equal sign, so that is correct. All right, letter C, I need to get x by itself. Right now I'm subtracting 2 from x, and I want to get rid of this, so x is by itself on one side of the equation. So to undo subtraction, I do addition. So I'm going to add 2 to both sides. Don't forget you have to do it to both sides. So I've gotten rid of that subtract 2 over here, and I just have x left, which is my goal. And on this side I have negative 9 plus 2. Now think about your number line. You don't have to draw it all out, but show 0 and show here's negative 9. And if you want to show the next number higher or so, you can. If I'm adding 2 from negative 9, I have to go up, remember, because when you add, you always go up. When you subtract, you go down. So I'm adding 2, I'm going to go up negative 8, negative 7 is where I'm going to end. So x is equal to negative 7. To check that, I plug negative 7 back in for x to my original equation. So I'm going to try negative 7 minus 2 is equal to negative 9. So negative 7 minus 2, think about your number line again. You're starting at negative 7. You're subtracting, so you're going down. So negative 7, 1, 2, negative 9. So my equation is correct. All right, for letter D, We're still trying to solve for x, get x by itself on one side of the equation. The way that we get rid of this fraction is by multiplying that fraction by its reciprocal, or you can think of that just as by the fraction flipped over on its head. This will get rid of that fraction and leave us with x. The reason for that is that on the top of this fraction, you have 2 times 1 is 2, and on the bottom of this fraction, you have 1 times 2 is also 2. So really here you have 2 over 2x. But 2 over 2 is equal to 1, so you just have x left over. If that doesn't make sense to you, that's okay, but just think about, or just remember that to get rid of a fraction, you have to multiply it by its reciprocal. Now we know we can't do something to one side and not the other, so we're also going to multiply this side by 2 over 1, or just multiplying it by 2. When I multiply by a fraction, and I want to do that on this side too, I would put this over 1. But that's really kind of silly because here I have 22 over 1 times 2 over 1. It's just the same thing as 22 times 2. So that's going to give me 44, or 44 over 1. So that's my answer for x. To check it, I need to plug in 44 back in for x. So I would take 1/2 times 44 and see if that's equal to 22. Now here's a place where I'd want to turn 44 into a fraction. So that when I multiply these, and I'm going to write my answer down here, I'd get 44 over 2. Now I'm going to simplify that. I'm going to divide the top and the bottom by 2. I know that 44 divided by 2 is 22. 2 divided by 2 is 1. So that's equal to 22. And that was what my original equation was. So this thing right here we just found is equal to 22. So I can write that 22 equals 22, and my equation is correct.